Okay, welcome back. Today's lesson is called Permutation Combination, and we are on page P14 of the textbook. Now, let's dive right into this. This symbol, okay, exclamation mark, means factorial. Okay, we read this as factorial. And if I write 3 factorial, this is not 3, I'm happy, but it is 3. What this means, we read this as not 3 exclamation mark, but 3 times 2 times 1. You know, I always joke, 3 I'm happy, you know, excitement. Okay, no, this is not 3 excitement, guys. This is 3 times 2 times 1. 3 factorial means 3 times 2 times 1. And here, let me say this. We run out of symbols in math, you know. They've exhausted every letter in the American alphabet. They've exhausted every letter in the Greek alphabet. They've exhausted every symbol on the keyboard. If you look on the keyboard of your computer, mathematicians have used the brace, they've used the bracket, they've used the parenthesis, the comma, the period. Any symbol you can find on your keyboard, we've already used. Okay, so we're begging for more symbols. So if you can invent symbols, okay, if you can invent symbols, I'm sure you can probably sell them to the math people, okay? The Society of Mathematicians, I'm sure, would say, yes, we'll take your symbol, but there's one they rejected, okay? There's one they wouldn't accept. I do know this one. They won't take this one. I don't know why. Okay, they have not put this symbol in math yet, okay? I think most students would say, no, I'm just joking. Okay, so we need more symbols, right? Okay, why? Because math people are lazy. They don't want to write 3 times 2 times 1. They want to just write 3 factorial. So what does 4 factorial mean? Okay, they got tired of writing 4 times 3 times 2 times 1. So what do they write? They just write what? 4 factorial. And if on the board if I wrote 5 times 4 times 3 times 2 times 1, this is not necessary anymore. All you have to do is write what? 5 exclamation mark, 5 factorial. Okay, that takes care of all of it. We read this as 5 times 4 times 3 times 2 times 1. So, let's go ahead and calculate these. 4 factorial, 5 factorial is 5 times 4 times 3 times 2 times 1. 6 factorial is 6 times 5 times 4 times 3 times 2 times 1. Go ahead and write these down. Okay, so take good notes on this, guys. This is I wouldn't say this is a hard lesson. This one, I guess we're just introducing formula today, but permutation combination can be a difficult topic for students. I said in the last video, it took me a while for me to visually and spatially understand these ideas, and many students, many people in math that are good at math struggle with these concepts. Why? Because you have to visually, spatially understand what's actually happening here. When we get to the problems, it's not so easy, but this will definitely save you time in writing. Okay, 6 factorial, 7 factorial is what? 7 times 6 times 5 times 4 times 3 times 2 times 1. All right, so we have to memorize these values. Why? Because you don't want to be calculating 7 times 6 times 5 times 4 times 3 times 2 times 1 in your quiz. Your quiz would take you a long time, same with your tests, but rather just memorize these. It would saves you a lot of time. 3 times 2 times 1 is 6. Now memorize these for quizzes, guys. Okay, so I will randomly ask you, what is 7 factorial? Okay, 4 factorial. Okay, do you see in 4 factorial, do you see 3 factorial? Look, I've underlined it. In 4 factorial, do you see 3 factorial? 3 times 2 times 1, which is 6, times another 4. 6 times 4 gives what? 24. Okay. And in 5 factorial, do you see 4 factorial? Okay. So 4 factorial is 4 times 3 times 2 times 1, and 5 factorial is 4 times 3 times 2 times 1, or 4 factorial times another 5. So we have 24, because 4 factorial is 24. We have 24 times 5, which is 120. 6 factorial, 6 times 5 times 4 times 3 times 2 times 1. Do you guys see 5 factorial times 6? Okay. You have 120 as 5 factorial times 6 is 720. Okay. In 7 factorial, do you see 6 factorial? 6 factorial is 720 times another 7, which is 5040. Now notice, these values are getting large very, very quickly. Okay, so factorial is huge. Okay, these values get big very, very quickly. We're going to talk about that. Now 2 factorial, what is 2 factorial? 2 factorial is 2 times 1, which is what? 1, I'm sorry, wow. 2 times 1, which is 2. And 1 factorial is what? 1 factorial is 1. Question. What is 0 factorial? What is, I'm going to erase this. What is 0 factorial? We're on page P14. What is 0 factorial? 0 factorial is, no, it's not 0, it's 1. What? What? You know, okay, 0 factorial is 1. When I first saw this, I said, why? And you know what my math teacher told me? He said, because. Okay, because. There you go. Because. And that was not good for me. I almost quit the subject of math altogether. Okay, so why? Because the math people said that that's the case. They got together, they had a little party, okay? Maybe they got together in England or Switzerland or whatever. All the great math people of the world get together in a little group, and they say, what are we going to do with 0 factorial? What are we going to do with it? We're going to call it 0? No, because if we call it 0, everything doesn't work. All of our formulas that we've created don't work. So what are we going to do about this? We're just going to call it 1. How does that sound? Let's just call it 1. So 0 factorial, write this. It's a definition you need to know. Okay, definition. It's called a fudge factor, if you want to say it. The slang term for it, it's a fudge factor. 0 factorial is 1. Fudge factor. It makes everything work. Why can they just do this? Why can I let people, math people, they're smart. I give them that. These strong math guys are smart. But what gives them the right to tell me that 0 factorial is 1? Okay, it makes no sense. And they're just going to tell me that it's 1, and I have to just accept that. All of a sudden, everything in math, I was always able to solve and find an answer. Okay, I was always able to solve and explain why something was the case. And now all of a sudden, I have to take this for someone's word. They just say, okay, it's 1, accept it. Okay, and I'm going to try to help you guys understand what a fudge factor is and what is a definition. Okay, it's something that you accept to be true, and you don't question it. Okay, now I think it'll make more sense why they did this later. Okay, I'll show you guys why they did this. And does it matter? No. Okay, but can it bother you for a while? Yeah. Okay, but I think once you start to understand what a definition is, okay, in this case I call it a fudge factor. It's a slang word, meaning it just makes things work. Okay, at that point when you start to understand the concept of what a definition is, you start to say, okay, we're okay with this. Now, permutation. Okay, you also have to have these on your definition sheet. Permutation of n objects taken r at a time. Permutation of n objects taken r at a time is n factorial over quantity n minus r factorial. Combination of n objects taken r at a time is n factorial over r factorial multiplied by quantity n minus r factorial. What are you saying? Okay, this looks crazy. All right, this is permutation. This is combination. Don't let them scare you. They're actually not that bad. Combination. The formulas look scary, but the formulas are actually kind of easy. Okay. Now for permutation, I want you guys to write the keywords for permutation are assignment, assignment after selection, okay, or arrangement. Okay, assignment after selection or arrangement. Combination, you can think group. Okay, remember the question I asked you in the last video. How many groups of 3 are there in 21 people? Okay, how many groups of 3 are there in 21? I told you guys this was 1,330 groups of 3 in 21. I'm going to show you why this is the case. Not in this video, but in the next video. Right now we're just going to learn how to use the formulas. Group. You can also think committee is another word they use. Not always. These are just keywords to help you. Or no, these are just keywords. It doesn't necessarily mean, if you see the word committee, it does not necessarily mean you're looking at a combination, but it can help. It can help you guys decipher between the two. Okay? Or no order within the group. No order within the group. Okay, so permutation is assignment after selection or assignment within the group or arrangement within the group. Okay, combination is just a group, a committee, or no order within the group. Now let's look at these formulas. Okay, now on page P14 of your textbook today, we're just concentrating on how to use the formulas. So looking at number 1, I'm just going to give you some quick examples, and this video is going to be done. You guys can work these problems out. We're looking at permutation of 5, choose 3. This is problem number 1. Problem number 1 on page P14. I will do the odds, and you guys will do the evens for homework. So the homework is page P14, numbers 2 through 8 even. Okay, numbers 2 through 8 even. Now, number 1 says permutation of 5 objects taken to 3 at a time. This is just a formula. Just use the formula. Okay, so you have to look here. Guys, permutation 5, 3. 5, 3. Look up here. Permutation NR. NR. So my question is, which one is N? Which one is N? N is what? N is 5. R is what? R is 3. Now, where does N go? N goes on top. N also goes on the bottom, and R goes on the bottom. And we subtract N and R on the bottom. Notice we have our factorial symbol. So what is this? Okay, well, permutation 5, choose 3. We're going to take our 5. That is our N. Okay? And we're going to put this where? On top. Okay, so we have 5 what? 5 factorial on top. And on the bottom, we're going to do what? N minus r. In this case, n is 5, r is 3. So we're going to do 5 minus 3 quantity factorial. Okay, 5 minus 3 factorial. Now, I want you guys to notice, n is 5, n is 5, r is 3. So where did n go? Notice everything matches up. N is 5, so we put 5 factorial on top. And n was 5, so we put the 5 here. R was 3, we put the 3 here, and we subtract. Now, don't do this. Don't do this. Here. Before we even go any further, my question is here. 5, here, look here. 5 minus 3 factorial. Does distributive property apply here? Is this distributive? My question is this equal to 5 factorial, subtract 3 factorial? The answer is no. 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 Don't make this mistake. There is no distributive property here. Just like I said with absolute value. Negative 3 times the absolute value of x minus 5. Does distributive property apply to absolute value? No. Well, technically, yes, there is a rule, but have I shown you guys what this rule is yet? No. So for right now, does distributive property apply to absolute value? No. Is this equal to the absolute value of negative 3x plus 15? Is this true? No. This is completely false. Do we distribute inside an absolute value? No. These are like what? Jail bars. Okay, so we don't distribute into an absolute value. Okay, no distributive property applies to absolute value. Also with factorial, no distributive property applies to factorial. Let me show you why. Look, maybe I have enough space here. Maybe you guys can see why. If we say here, I'll show you what is correct. Quantity 5 minus 3 factorial. Please excuse my aunt says that we do parenthesis first, exponent second, multiplication third, addition last. We do parenthesis first. So what are we going to do first? We're going to do parenthesis. We're going to do 5 minus 3. 5 minus 3. This is correct. This is correct. This is good. 5 minus 3 is what? 2. So we get 2 what? 2 factorial. And we know that 2 factorial is what? 2. So 2 factorial equals 2. The correct answer is 2. If you try to distribute, watch. This is wrong. This is wrong. This is wrong. 5 minus 3 factorial. This is wrong. If you try to distribute, you get 5 factorial minus 3 factorial. This is wrong. This is wrong. Over here. Okay, this is wrong. 5 factorial minus 3 factorial. Now we know that 5 factorial is 120. We know that 3 factorial is 6. We get 120. 120 minus 6, which is 114. So obviously you see that's not correct. The correct answer is 2. Okay, so again, does distributive property apply to factorial? No. Does distributive property apply to absolute value? No. Okay, so again, going back to this formula, what are we doing? We're doing 5 factorial stays the same on top over. We subtract first. 5 minus 3 is what? 2 factorial. Now, I want you guys to omit this step. We're going to try to save time. Save time. Can we skip this step? Look what we did. Look what we did. Where did the n go, or the 5? The 5 went on top, so we ended up with what? 5 factorial. On the bottom, what did we do? We subtracted 5 and 3. 5 minus 3 is what? 2. So we ended up with 2 factorial on the bottom. Look up here. It says put your n factorial on top. On the bottom, subtract the n and the r. And that's your factorial for the bottom. So we have 5 factorial on top, and on the bottom, just take your 5 and 3 and subtract. 5 minus 3 is what? 2 factorial. Okay, so now what do we have? I want you to write this out. We have 5 times, remember, 5 factorial means 5 times 4 times 3 times 2 times 1 over 2 factorial is 2 times 1. Do not think that 5 factorial is 5. No, 5 factorial is big, guys. 5 factorial is not 5. 5 factorial is what? 5 factorial is a big number. 5 factorial is 120. So we have 5 times 4 times 3 times 2 times 1. Notice all multiplication. Do you see any addition in this problem? No, you see all multiplication, so we can cancel. So we're going to cancel 2 times 1, the 2 times 1, and what is left? What is left? If we cancel the 2 and the 1 with the 2 and the 1, do we get 1s or zeros? Do we get 1s or do we get zeros? Okay, my question is, do we get 1s or do we get zeros? The answer is you get 1s. Okay, and do we write these 1s? No, we don't actually write these 1s. Here, let me show you again. Pay attention to this now. 8 over 4. Question, what is 8 divided by 4? 8 divided by 4 is 2. We know that the correct answer is 2. Now my question is, if you cancel 4 with 8, divide them each by 4. 8 divided by 4 is 2. What is 4 divided by 4? 4 divided by 4 is 1. Do we write the 1? No, we don't write the 1. But students, do you put a 0? Is 4 divided by 4 0? No, you put a 1, right? Okay, but in this class, we don't actually write the 1. Okay, so you understand that this is 2 over what? 2 over 1, which is 2. Now, look at this. You know, I think this makes it very clear. What's 4 divided by 4? 4 divided by 4 is 1. Okay, so if we cancel the 4s, you understand that the correct answer is 1. If we cancel the 4s, do we get zeros? Do we get zeros? No. What do we get? We get what? We get 1s. We end up with 1 over 1, which is just 1. Now, do we actually write these 1s? No. You understand that 4 divided by 4 gives a 1, 4 divided by 4 gives a 1, 1 over 1 is what? 1. We understand 1s. Why? Because it's not necessary to write 1 times 1 times 1 times 1 times 1. It's redundant. So we're going to say here, 2 and 1 cancel with 2 and 1. What are we left with? We're left with 5 times 4 times 3, which is 20 times 3 or 60. Now, another way that you could have calculated this, notice, you could have just memorized this. Watch, I'm going to erase. Do you see that 5 factorial over here is what? 120. So we have 120 over, and 2 factorial. 2 factorial is 2. So we have 120 divided by 2. And 120 divided by 2 gives what? 60. Okay, so you see your correct answer is 60. Now, let's look at, this was question number 1. Let's look at combination really quick with the same type of question. Okay, so we understand our answer over here. I'm just going to erase. We understand our answer to be 5 times 4 times 3 times 2 times 1 over 2 times 1. 2 times 1 cancel the 2 times 1, leaving 1s that we don't write. And we get an answer of what? 60. I'm going to have to erase back because I'm out of space. 5 times 4 times 3 times 2 times 1 over 5 factorial over 2 factorial equals 5 times 4 times 3 times 2 times 1 over 2 times 1. These cancel, leaving 60. Now, let's look at, before we go on to the next question, let's look at combination 5 choose 3. Okay? And I want to compare combination 5 choose 3 with permutation 5 choose 3. Now, our combination formula is a little different but very similar. Notice, what is our n? N is what? 5. What is r? R is 3. Okay? And where does the n go? Okay, so our 5 is n. This goes on top. So we write 5 factorial on top. And notice, we have an additional value in the denominator of the combination formula that is not in the permutation formula. We have an r factorial. So what goes next? What is our r value? R value is what? Our r value is what? 3. R value is 3. Notice we put an r factorial, so we're going to put a 3 factorial. And notice we have multiplied by quantity, quantity n minus r. So we take the n and the r, 5 and 3, and subtract. 5 minus 3 what? Factorial. So we end up with 5 factorial over 3 factorial times 5 minus 3. Remember, we don't distribute the factorial. 5 minus 3, we do what's inside parentheses first, is 2. So we end up with 2 factorial. 3 factorial times what? 2 factorial. And notice these formulas. Look at this and look at this. These formulas look very similar, except what do we have in the denominator? We have an additional factorial in the denominator. And this is your r factorial. Okay, in this case, r was 3, so we have that r factorial in the denominator. Now let's write this out. So we have 5. Oh, question. Can we skip this step? Can we skip this step before we go any further? Can we skip this step? Yes. Do you guys see that we can just subtract the 5 and the 3 in our head and get what? 2 factorial. So I'm going to go backwards and skip that step. Let's go back. So combination formula says we put our n on top, we put our 5 factorial on top, and on the bottom we put our r factorial first, which is 3 factorial, and then multiply by subtract the 2. 5 minus 3, and this is what I'm going to do for the rest of the problem. Subtract the 2. 5 minus 3 is what? 2 factorial. If you need to, go back and rewind to watch the beginning of the video if you get confused later. Okay, now, so we have 5 factorial means 5 times 4 times 3 times 2 times 1 over 3 times 2 times 1 times 2 times 1. Now notice, we have 2 factorials in the denominator. We have a 3 factorial and a 2 factorial. Here's your 3 factorial. This is your 2 factorial. Question, which one do we want to cancel at the top? We always want to cancel the larger factorial as much as possible. So start with your 3 times 2 times 1 with your 3 times 2 times 1. Okay? We cancel the large factorial first, then we cancel the small factorial in the denominator, the 2 times 1. Now, again, is it necessary to write the times 1? No, but for now, on the end of your factorial, go ahead and leave it. So 2 times 1, okay, so can we cancel the 2 with the 4? Divide them each by 2. 2 divided by 2 is 1. Do we write the 1? No. 4 divided by 2 is 2. We get 5 times 2 is 10. Now I'm going to show you a shortcut. I'm going to show you a shortcut here. Watch. instead of writing 5 times 4 times 3 times 2 times 1, could we just simply do this? Could we write 5 times 4 times 3 factorial over 3 factorial times 2 times 1? What am I doing here? A couple things. First off, what is the factorial symbol used? Okay, it's used to represent, we don't want to write 3 times 2 times 1, we just want to write 3 factorial. This symbol is used to save time. So which factorial do we use? Well, we stop. So when you're going down, notice, here, let's go back to the original. When going down, you have a 5 factorial, we can just write 5 times 4 times, what factorial do we want to stop at? We don't want to write 3 times 2 times 1. Notice, what is our largest factorial in the denominator? Largest factorial is 3 factorial. We can stop at 3 factorial. And does this mean 3 times 2 times 1? Yes. And on the bottom we have what? 3 factorial times 2 factorial. Now, our 3 factorials always cancel your larger factorial. The 3 factorials cancel. Question, did you cancel 3 with 3? No. Okay? You did not cancel 3 with 3. Guys, what is the value of 3 factorial? It is 6. This is a big number. You canceled what? 6 with 6. 6 with 6. Okay, so what are we left with? We're left with 5 times 4 is 20 over 2 factorial is 2. Okay? Or let's do it like this. Can we cancel 2 factorial, which is a value, I'm going to erase it, and just write 2. Can we cancel our 2 with our 4? Yes. 2 divided by 2 is 1. We don't write it. 4 divided by 2 is 2. We get 5 times 2, which is 10. Now I want you to notice, these formulas look very similar. We have combination 5, choose 3. We have permutation 5, choose 3. Which value is larger? Which value is larger? Okay, hopefully you notice permutation is a larger value. So which of these is bigger? Permutation or combination? Okay? Permutation is the bigger value. This is the big value. Okay? This is bigger than combination. Okay, that's going to be important for the next lesson. Now, let's go to the next problems. We're just going to knock these out very quickly. Okay, number 3 says permutation 7, choose 5. Number 3 is permutation 7, choose 5. Okay, again, going back to our permutation formula. What goes on top? N goes on top. In this case, n is 7, so we have 7 factorial over. And on the bottom, we're going to skip. On the bottom, we see that we subtract n and r. Since n is 7 and r is 5, subtract these. This saves time. 7 minus 5 is what? 2. So we get 2 factorial. Now let's save some time here. Okay, so we're going to write 7 times what? 6 times 5 times 4 times 3 times... Do you want to write 2 times 1? No. Instead of writing 2 times 1, we're just going to write what? 2 factorial over what? 2 factorial. And notice, 2 factorial cancels with 2 factorial. Okay, and you're left with 7 times 6 times 5 times 4 times 3. And this is, well, you combine. 7 times 6 is 42. You can do this in one multiplication problem. 5 times 4 is 20. 20 times 3 is 60, so this is 60. And all you have to figure out is what is 42 times 60. Okay? And this is 240, 252, 2520. Okay, 2520. Okay, 2,520. Let me see, 5 times 4 is 20, times 3 is 60. So it's 42, yeah. 6 times 4 is 240, 252, 0, 2520. Now, number 5. Question number 5 says combination 6, choose 1. Oh, let me say this. Guys, how many ways can you select 5 people out of 7? How many ways can you select 5 people out of 7 and assign them position of 1st, 2nd, 3rd, 4th, 5th place? How many ways can you choose 5 out of 7 and assign position? Okay, you have 2,520 ways. It blows your mind. How many ways can you select 5 out of 7? This is what we're going to be getting at in the next lesson. 5 out of 7. 5 people out of 7, then assigning prizes of 1st, 2nd, 3rd, 4th, and 5th. Notice the word assignment of prizes. Assignment of prizes is 2,520 ways you can choose 5 people out of 7 and assign them prizes. Okay. Now, number 5. Number 5 says combination of 6, choose 1. Combination 6, choose 1. Okay. So we're going to use our combination formula. Okay. So what goes on top? N is 6. R is 1. So we're going to put the n factorial on top. We have 6 factorial over, what goes first? What goes first? R factorial goes first. Since our R value is 1, we put 1 factorial. And let's skip a step. N minus R, do this in your head. N minus R, do it in your head. We do n, which is 6, R, which is 1. Subtract those in our head. 6 minus 1 is what? We multiply by 5. 6 minus 1 is 5, what? Factorial. Now, this is 6 times hold on. Do you want to write 5 times 4 times 3 times 2 times 1? No. These symbols are here to save us time. 5 factorial is what? 5 factorial is 120, or instead of writing 5 times 4 times 3 times 2 times 1, we can just write what? 5 factorial over. Do you guys see that 6 times 5 factorial is the same as 6 times 5 times 4 times 3 times 2 times 1? Which takes less time to write? Second. Okay, the bottom one takes less time. So just write 6 times 5 factorial. Why did I stop at 5 factorial? Because there is a 5 factorial in the denominator. So we have 1 factorial times 5 factorial. And question, what is 1 factorial times 5 factorial? Well, we know the value of 1 factorial. 1 factorial is just what? 1. Okay? So we can say 1 times 5 factorial. Do you guys agree that 1 times 5 factorial is just 5 factorial? Okay? Now we're going to cancel. Did we cancel? Question, did we cancel 5 with 5? No. Okay? We canceled a big number with a big number. 5 did not cancel with 5. No, we canceled what? We canceled 120 with 120. Here. Just to make this come to life for you guys. A computer, I don't know, the Google calculator, if you go onto the Google calculator online and type in 100 factorial, I don't even know if the Google calculator will do 100 factorial. Guys, 100 factorial is more atoms, I guarantee you, more atoms than there are in the entire Earth. Okay, so if I take a piece of dust, piece of dust. Okay, here's a piece of dust. Piece of dust on my finger. That piece of dust has millions of atoms in it. Okay, millions, beyond your comprehension, atoms in that piece of dust. Okay, you fly in an airplane, you look down at the earth. Okay, a semi, okay, when you're on a highway, a semi looks big. Okay, it looks big. But when you're from a plane looking down on the earth, a semi looks like a piece of dust. Extremely small, hardly visible if you ever flown in a plane. Okay, so if you look down from a plane, you start looking at the earth, a semi looks like a piece of dust. Okay, the earth is huge. Okay, if there's millions of atoms in this piece of dust, okay, and yet we're looking at the size of the earth, how many atoms are in the earth? Guys, 100 factorial. 100 factorial is so big. Okay, it's more atoms than there are in this entire earth. Okay, now, here, let me show you. Factorial values get large very, very quickly. Look, 8 factorial. 8 factorial is 40,320. Okay, 9 factorial is 362,880. Okay, so we're getting big very quick. 10 factorial is 3,628,800. Okay, 11 factorial. 11 factorial is around 36, close to 40 million. Okay, 12 factorial, we're at 400 million. 13 factorial, we're at 4 billion. More than 4 billion. At 14 factorial, we're at 40 billion, and etc. Hey, guys, 20 factorial. 20 factorial is beyond a trillion. Okay, beyond a trillion. Okay, trillion is you could never count. If you tried to count to a trillion, here's perspective. If you tried to count to a trillion, it would take you 10,500 a year. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, 33. You try to count as fast as you can to a trillion. It will take you 10,500 years to count to a trillion. You will never, ever be able to count to a trillion. 20 factorial is much bigger than a trillion. Huge. Okay, so 20 factorial is huge. Much, much bigger than a trillion. So when we start talking about 18 factorial, when you cancel, look, when you cancel 18 factorial with 18 factorial, you can think of this as canceling not 18 with 18, but like a trillion with a trillion. Okay, huge number cancels with huge number. Okay, now going back to this, 5 factorial, did we cancel 5 with 5? No, we canceled what? 120 with 120. So we got rid of some big numbers. What are we left with? We're left with 6. Just 6. Okay, all that for that. Okay, no, here, look. Combination 6, choose 1. We're talking group. Okay, how many ways can we select one person out of 6? This is obvious. How many ways can you select one person out of a group of 6? 6 ways. Okay, makes sense. All right, now, next problem, last one. Number 7, permutation 9, choose 5. Number 7, okay, permutation 9, choose 5. Use our formula. We do what? What goes on top? The n. Okay, n is 9. So we have 9 factorial on top, over. On the bottom, we subtract the 2. 9 minus 5 is what? 4 factorial. End up with 9 times 8 times 7 times 6 times 5 times what? We stop at what? We're going to stop at what? 4 factorial. Stop at 4 factorial. and we're going to cancel the 4 factorials. Now question, are we canceling 4 with 4? No, we're canceling what? 24 with 24. So cancel your 4 factorials. We're left with 9 times 8 is 72, 7 times 6 is 42, times 5 is 210, or 5 times 6, yeah, 210 times 72, okay? So we have 210 times 72 is 0, 2, 4, 0, 7, 14. This will make, okay, 0, 2, 1, carry the 1, 15, 15,120. So our answer is 15,120. So you guys have to multiply this 15,120 ways. Okay. Now, just before we end this video, let me just quickly do one more combination. 8. Okay. Or no, not question 8. What am I saying? Let's just do combination 9, choose 5. Combination 9, choose 5. And so again, going to the combination formula, the question, is combination 9, choose 5 going to be smaller or bigger than permutation 9, choose 5? Hopefully you say permutation is what? The big value. So if we have identical numbers, 9 and 5, 9 and 5, the combination value will be smaller. Okay? So we have combination formula. Remember, n on top, so we have 9 factorial on top. And on the bottom, we start with the r factorial. Okay? So since we have 5 for r, we have 5 factorial multiplied by, subtract the 2. 9 minus 5 is what? 4 factorial. Now when we write this, 9 times 8 times 7, where are we going to stop? Where are we going to stop? We're going to stop at our larger factorial. 9 times 8 times 7 times 6 times what? 5 factorial over 5 factorial. And I want you to take your smaller factorial, 4 factorial, and write it out. 4 times 3 times 2 times 1. So we're going to cancel the 5 factorial with the 5 factorial. What did we just cancel? We canceled 120 with 120. Now we're going to cancel the 4, 3, 2, and 1. This will always, the small factorial will always cancel with everything in the numerator. So watch. We're going to cancel the 4 with what? 4 cancels with 8. Divide them each by 4. 4 divided by 4 is 1. Do we write the 1? No. 8 divided by 4 is 2. Now, do we have a 2? Yes. Can we cancel the 2 with the 2? What's left over? Do we have zeros or 1s? Okay, hopefully you say we have 1s. We don't write the 1s. Okay, now, we're going to cancel 3 with, pick a value, 6. Okay, divide 3 by 3, we get 1. 6 divided by 3 is 2. Our final calculation is 9 times 7, which is 63 times 2, is 126. So notice how much smaller. The value up here for the permutation was 15,120. For your combination, you just have 126. Look at the difference. Okay? Now, again, 4 with 8 gave a 2, 2 cancel with 2, 3 with 6, 2, yeah, 7 times 2 is 14, 99 is 14, yeah, 126. So you see that your combination value is much smaller. So combination 9, choose 5 is much smaller than permutation 9, choose 5. All right, that concludes this video.